Hey everyone, and welcome to the final episode of Editing Humanity. I'm Giancarlo, and today's episode is a little different. It's not about just one CRISPR breakthrough or one interview. This time, we're taking a step back and looking at everything we've learned.
Over the course of this series, we have talked to scientists, students, researchers, and thinkers who are all wrestling with what it means to edit life itself. We have gone from the basics of gene editing to deep conversations about ethics, access, risk, and responsibility.
For this last episode, we're having a roundtable. We've gathered all six of us, your host, your producer, and the voices behind the mic, to reflect, debate, and wrap up this journey the best way we know how, by asking the big questions and being honest with ourselves and each other.
Before we dive into the ethics, let's go around and each share a quick recap of our favorite episode or moment from the series. What stuck with us, what surprised us, what changed the way we think about CRISPR.
In my episode, Professor Schwartz and I explored the many sides of CRISPR, one of the most groundbreaking and controversial tools in modern science. We covered the risks of unintended genetic changes, the debate between treatment and enhancement, the potential for environmental impact, and the growing concerns around inequality and accessibility. We questioned how far this technology should go. Should it stop at curing diseases, or should we open the door to editing traits like intelligence and appearance? Right now, science isn't ready, and ethically, society might not be either. We discussed fairness, who gets access, and who gets left behind. We talked about ecosystems, genetically modified crops, and the risk of unintended consequences when gene editing organisms are introduced to the wild. And we dove deep into questions of consent, especially when editing embryos or affecting future generations. While it's easy to get caught up in fear, the fear of designer babies, super soldiers, or genetic inequality, we can't let that fear blind us to the potential for good. CRISPR isn't inherently dangerous or ethical. It's a tool. How we use it will depend on the choices we make as a society, as scientists, and as individuals. Instead of focusing only on the worst case scenarios, we should also recognize CRISPR's power to heal, to help, and to solve problems we've struggled with for generations. This episode reminded me that progress doesn't have to come at the cost of ethics. With the right safeguards, clear guidelines, and global conversations, CRISPR can be part of the better future, not just a risk we have to avoid, but a responsibility we have to manage wisely. So let's stay informed, stay curious, and keep asking questions. Because understanding CRISPR isn't just about science, it's about shaping what kind of world we want to live in.
Hey everyone, this week on Editing Humanity, I sat down with Dr. David Eric John, a professor at NAU, with deep experience in microbiology and molecular biology. When we got into CRISPR, I asked about the biggest ethical challenges he sees with CRISPR. He brought up three major areas. First, the fear of designer babies. He said we might one day have the ability to, quote-unquote, craft human beings with genetic traits that allow them to be, maybe great, like super beings. But also warned about the dark side, creating a servant class if technology is abused. Second, he pointed out the very real risk of using CRISPR therapies. While treatments are targeting diseases like cystic fibrosis and cancer, there's a serious danger of causing unintended harm, like triggering cancer through off-target mutations. In his words, you don't want to do worse harm with the technology you're employing. Third, we talked about embryo editing. Editing embryos could have massive unintended consequences if anything were to go wrong, and as of right now, it's illegal in most regulated countries. He emphasized that editing embryos carries much higher ethical weight than editing individual cells for therapy. We also spent time talking about access and equity. CRISPR-based therapies are incredibly expensive right now, like CAR T therapy for cancer, which he said can cost hundreds of thousands of dollars. He pointed out the concern that those with exceptional means could have access to something that other people simply don't. Basically, there's a very real risk of widening healthcare inequality unless we figure out how to fund and regulate this fairly. Speaking of regulation, we talked about who should be making these rules. He suggested that in the US, it should be a collaboration between agencies like the NIH and Congress, but he did admit that Congress can move slow, which could halt progress. He also pointed out that biotech companies operating privately could push boundaries unless strong laws are passed. Finally, he compared regulation across countries, mentioning that even places like China, despite their different political systems, are still cautious about embryo editing. The big takeaway he left us with is that most people are comfortable editing individual cells to cure disease, but when it comes to embryos and altering human development at the earliest stages, that's where most of the ethical red lines are drawn.
I reflected on the complex and far-reaching conversation I had with Dr. Hodge. From germline editing to the ethics of designer babies, the potential of CRISPR to reshape our biology and even our future raises more questions than answers. Should we permanently alter the human gene pool? Can we enhance without crossing moral lines? And if we do move forward, who gets access and who gets left behind? We also explored the darker sides of innovation, unintended consequences, bioterrorism, and ecological disruption, and the risk of CRISPR falling into the wrong hands. Regulation, oversight, and informed consent emerged as recurring themes, especially when decisions were made today can affect generations to come. Should there be a global standard, or should each country define its own path? And how do we maintain transparency to preserve public trust in a technology that's advancing faster than policy can keep up? In the end, the question still stands. Do the pros outweigh the cons? Dr. Hodge was of the mindset that while this tool can have massively good effects, it is very dangerous and should be looked at carefully. Its impact will be defined by how we choose to use it, how we ensure equity, and how we balance scientific progress with ethical responsibility. The future of gene editing is not just a scientific issue, it's a societal one.
Reflecting on the combination of CRISPR and IVF, it's clear that we are in a new era of reproductive medicine. IVF has already transformed the way we approach infertility, offering hope to millions, but genetic challenges still pose significant hurdles. CRISPR presents a groundbreaking solution by enabling precise edits to embryos before implantation, potentially eliminating harmful genetic mutations and preventing inherited diseases. This technology goes beyond traditional IVF, which only selects embryos based on genetic screening by actively correcting genetic issues. However, with this powerful technology comes a host of ethical concerns. One major issue is the potential for genetic enhancement, using CRISPR not just to eliminate diseases, but to select for traits like intelligence, physical appearance, or even personality. This raises troubling questions about designer babies and whether we should make decisions about the genetic makeup of future generations. Who decides what traits are desirable and how might this impact societal inequalities? Additionally, there's the concern of unintended consequences. While CRISPR holds enormous promise, its long-term effects are still unknown, and we don't fully understand the risk of altering the human genome. There's the possibility of off-target edits where unintended changes to the DNA could cause harm or create new genetic issues. Looking ahead, the potential benefits of CRISPR and IVF are undeniable. It could lead to healthier, disease-free generations. However, as we push forward with this technology, it's crucial that we navigate the ethical dilemmas it presents. Balancing the excitement of scientific progress with careful ethical consideration will be key in shaping how we use CRISPR responsibly in the future of reproductive medicine.
When I first started reading about CRISPR, the science felt almost magical. The idea that we can precisely edit genes, that we could make crops more drought resistant, eliminate invasive species, and even stop diseases like malaria by altering mosquitoes, that sounded like the future, a hopeful one. But here's the thing, every solution comes with trade-offs. What started as a wonder turned quickly into questions. Who decides what counts as a pest? What happens when you release a gene-edited organism into the wild? Can you ever truly predict the outcome? My interview with Dr. Vissa taught me that CRISPR, especially in environmental contexts, is not just about science. It's about power, responsibility, and humility. One idea that really stuck with me was this: ecosystems are not machines. You can't tweak one part and assume everything else stays the same. It's more like a web. Tug on one thread and the whole thing shifts. Maybe it holds, maybe it doesn't. Environmental ethics also means asking, Who's affected and who gets a say? Ecosystems don't have voices. Future generations can't weigh in. And often, the people living closest to the land, indigenous communities, rural farmers, people in the global south, are left out of the conversation. That's a huge problem. Technology without equity is just another form of control. If CRISPR is used to alter environments, we need everyone at the table, not just scientists or policymakers in labs halfway around the world. So here's where I've landed, for now. I still believe CRISPR holds amazing promise. It could help us repair some of the damage we've done to the planet. But it demands serious caution, deep listening, and ethical humility. We need to slow down, not because we're against progress, but because we care enough to get it right.
In my episode, we interviewed a graduate student working in microbiology research to explore how CRISPR is currently being used in pharmaceutical and microbial settings. Throughout the conversation, we worked through 20 curated questions that centered around the ethical dimensions of CRISPR in everyday lab work. Questions that often go unasked when editing genes in non-human systems. A key theme that emerged was how easy it is to forget, in microbial research especially, that gene editing is still a significant intervention with real-world consequences. The guest emphasized that even though microbes aren't human, the responsibility to consider ethical implication doesn't disappear. In fact, being intentional and transparent about those implications can help prevent larger issues down the road. We discussed the practical side of ethical awareness, how thinking critically about your research decision isn't just good science, but also a smart financial move. In an era where research funding is tight and cuts are common, avoiding ethical oversights can save labs from costly delays, failed approvals, or even public backlash. Another important part of the episode focused on the gap between the public perception and the current reality of CRISPR. The guest helped debunk some of the common myths, clarifying that most CRISPR applications today are far from editing human genomes, in a designer baby sense at least. Instead, the work often happens in bacteria and model organisms, with the goals like vaccine development, improved drug manufacturing, or understanding disease pathways. Finally, we talked about the crucial role of science communication. As our guests pointed out, reducing stigma around CRISPR starts with making the science more accessible and understandable to the public. When people know what the technology can and can't do, it paves the way for more balanced conversations and better regulations, ones that promote both innovation and accountability. This episode was a reminder that ethics in science isn't a checkbox. It's an ongoing mindset, especially in fields as powerful and fast-moving as gene editing. All right, now that we have looked back, let's look forward, because CRISPR isn't just about science, it's about choice. And today, we want to ask some of the toughest ethical questions in this technology raises. So this is how this is going to go. We'll pose a question and each one of us will weigh in what we think and what we feel and what still doesn't sit right. Ready?
Should CRISPR be used to enhance human abilities beyond disease prevention?
CRISPR's potential to enhance human abilities beyond disease prevention is a controversial issue. While it offers the ability to eliminate genetic diseases, using it for enhancement, such as improving intelligence or physical traits, which raises significant ethical concerns. It could create new social inequalities if only the wealthy have access to genetic enhancements, deepening divides based on the desirable traits like intelligence or appearance. Additionally, altering the human genome for enhancement could have unintended consequences. The genome is complex, and editing one gene might affect other aspects of health in ways we don't yet understand. Using CRISPR for non-medical traits could also reduce human diversity, leading to a world where people are designed to meet societal standards rather than embracing natural variation. While CRISPR offers great promise, its use for enhancement demands careful, ethical consideration to avoid unintended consequences. Who gets to decide what normal or healthy looks like when editing genes?
That's a heavy one. And honestly, one of the most important questions we can ask when talking about CRISPR. The truth is, there's no single answer. Normal and healthy aren't just scientific definitions. They are deeply cultural, social, and even personal. In the podcast, we talked about how genes don't operate in a vacuum. One person's deficiency might be another person's uniqueness, or even strength, depending on the context. So who gets to decide? Right now, it's a mix of scientists, doctors, governments, and sometimes the market. What's popular? What's in demand? What can be funded? But that can get dangerous fast. If decisions are based on profit or social bias, we risk reinforcing stereotypes, erasing diversity, and marginalizing people who don't fit into a narrow mold of what's considered ideal. That's why ethical conversations like this are so important. The decision of what genes we edit and why can't just be left to labs and legislation. It needs to involve communities, patients, ethicists, and people with lived experiences of the conditions we're trying to fix. The line between treating disease and shaping identity is thin. And if we're not careful, gene editing could shift from a medical tool to a social filter. That's why we need to constantly ask, not just can we do this, but should we? And who's making the call? How do we balance the need for innovation with the risk of unintended consequences?
Balancing the push for innovation with the risk of unintended consequences is a tricky but important challenge. On one hand, innovation drives progress. It helps solve problems, improve lives, and opens up possibilities we never thought were achievable. But at the same time, if we're not careful, it can create new problems we did not see coming. The real question is, how do we keep moving forward without causing harm along the way? A good starting point is to think ahead, not just about what an idea can do right now, but what it might lead to down the road. This means asking questions like, what could go wrong, or who might be impacted by this? Bringing in different perspectives, scientists, people from affected communities, and ethics committees help catch blind spots early. It's not about slowing things down, but about building something more thoughtful and resilient from the beginning. It also helps to test ideas on a small scale before going all in. Pilot programs, early feedback, and being open to course corrections can make a huge difference. And of course, transparency matters. People want to know how decisions are made and who's responsible if things don't go as planned. That's where smart, flexible regulation can come in, not just to shut down innovation, but to guide it in a responsible direction. At the end of the day, taking risk is a part of innovation. We're never going to get everything perfect, but if we stay curious, listen to others, and keep asking the right questions, we can build a great future.
Is it ethical to use CRISPR on organisms, like microbes or animals, for human benefit?
That is a big question. Is it ethical to use CRISPR on organisms like microbes or animals for human benefit? And I think the short answer is it can be, but only if we approach it with the right mindset and safeguards. In my podcast episode, as I mentioned, I sat down with a grad student working in microbiology research, and this was one of the core topics we kept circling back to. The thing is, when you're using CRISPR in microbes, especially in a lab setting, it is easy to forget that you're doing something huge. You're literally altering genes. You're changing the biology of a living organism, even if that organism is something as tiny as E. coli. Because microbes don't have faces or feelings in the same way animal or humans do, the work can feel very distant from the ethical debates we hear about in mainstream conversations like designer babies or gene editing embryos. But just because we don't see the impact immediately, or because we're not working with humans directly, doesn't mean that we should treat it lightly. The guest on our podcast episode brought up a really important point. The ethical weight of using CRISPR doesn't disappear just because we're working with microorganisms. These microbes are a part of ecosystems, sometimes even the human body, and our modifications could ripple out in ways that we don't fully predict. So yes, CRISPR can absolutely be used for human benefit, like developing vaccines, producing insulin more efficiently, or even understanding diseases. But that benefit has to be balanced against the risk and the responsibility we have as scientists. One argument in favor of using CRISPR in microbes or animals is that it can reduce harm overall. For example, if editing a strain of yeast helps us create more cheaper, more accessible drugs, that's a huge win for public health. If modifying mosquitoes could prevent the spread of malaria, and that could save hundreds of thousands of lives every year, I don't see why not. But the ethical green light here depends on how careful, transparent, and community conscious we are in making those changes. Who benefits? Who might be harmed? Are we asking for permission, or are we just assuming we have the right to tinker with life? There's also a really practical angle to this conversation that I hadn't thought about much until my episode. Being ethically conscious can actually save time and money. With all the recent funding cuts in research, avoiding mistakes isn't just a moral issue, it's a financial one. If experiments go wrong or off the rail because you didn't think through the consequences of your edits, or if public backlash derails your project, the setback could be massive. Taking time to consider ethics upfront can help you avoid those pitfalls. So even if somebody isn't motivated by moral questions, there's still a very real incentive to think ethically. Another piece we touched on in the episode was public stigma. A lot of people hear CRISPR and immediately think of sci-fi horror stories like designer babies, gene-edited soldiers, or dystopian control of DNA. But what actually is happening in labs right now is so far removed from that. We are mostly working on microbes and animal models to better understand disease and improve treatments. The disconnect between what CRISPR is and what people think it is causes a lot of fear, and that fear can turn into resistance, especially in policy making. That's why science communication matters. If we want the public to support ethical CRISPR use, we have to be honest, clear, and open about what we're doing. Public shouldn't feel like this technology is being used or being developed behind closed doors. And making the science accessible can help the public push for better, more informed regulations. One that don't block innovation, but still hold researchers accountable. So coming back to the question, is it ethical to use CRISPR on organisms for human benefit? And drum roll, I think the answer is yes, but with a huge asterisk. It depends on how it's used, what safeguards are in place, whether we have considered the long-term impact, and whether we are involved the public in the conversation. The power of CRISPR is massive, and with that power comes an equally massive responsibility.
How should access to CRISPR-based treatments be handled to ensure equity?
Access to CRISPR-based treatment is currently a major challenge due to their extremely high costs. Some therapies can cost hundreds of thousands of dollars. This raises the risk that only individuals with exceptional financial means would be able to afford these life-saving treatments, while many others would be left without access. Biotech companies are working to reduce the burden of these costs, but as private entities, they may not be able to offer therapies at low prices. Insurance companies are also concerned about covering such expensive treatments, adding another layer of complexity to the issue. Government support for healthcare and research development are also uncertain at times, which further complicates efforts to ensure broad access to CRISPR-based therapies. Without stable public investment, it becomes difficult to fund research, infrastructure, and programs necessary to make these treatments more affordable and widely available. Dr. John emphasized that without significant public support, many promising advances in CRISPR technology could be delayed or limited to only those who can afford them privately. To ensure equitability, CRISPR treatments would require a combination of greater government investment, stronger insurance coverage, and broader public funding or assistance programs. Without these measures, there is a serious risk that advanced medical technologies like CRISPR could deepen existing social and economic divides. Addressing these challenges early is critical to prevent a future where only a privileged few benefit from the life-changing potential of genetic therapies.
What responsibilities do scientists have when the technology they create can be misused?
Scientists must rigorously follow safety protocols and ethical guidelines when working with CRISPR, especially in human, animal, or environmental gene editing. This includes limiting germline editing to lab research until safety, ethics, and social consensus are in place, and avoiding dual-use risks, modifying genes in ways that could lead to bioweapons or unintended ecological consequences. Additionally, CRISPR experiments, especially those with profound implications, should be shared openly with the scientific community and reviewed critically. The scientific community condemned the case of He Jiankui, who created the first gene-edited babies, partly because he acted in secrecy, bypassing ethical norms and peer input. Additionally, scientists have a responsibility to explain CRISPR's benefits, risks, and limitations to the broader public. This means participating in public forums, helping design inclusive democratic processes for deciding how CRISPR should be used, and advising lawmakers on appropriate regulations. This is because CRISPR technology develops faster than regulations can keep up. Scientists should help create ethical frameworks, propose moratoriums or temporary halts when necessary, and push for global cooperation. Gene editing doesn't respect borders, so international dialogue is crucial. Additionally, where possible, CRISPR systems should be designed to reduce the likelihood of misuse. This could involve biological containment strategies, such as making edited organisms unable to reproduce in the wild, built-in safety switches, creating systems that limit off-target effects or accidental mutations, and additionally, scientists must consider the social consequences for editing for intelligence, physical traits, or disability, and work with ethicists, sociologists, and affected communities, not just other scientists.
Those are the kind of questions that don't really have clean answers, but they're the ones that matter most, and they're going to keep evolving, just like the science.
To close out this episode and this whole series, we each want to share what this journey has meant to us, what's changed, what stayed the same, and what we're still thinking about.
After finishing this podcast, I've gained a much deeper understanding of CRISPR, not just as a tool for gene editing, but as something that brings up huge ethical, social, and scientific questions about our future. At first, I was honestly pretty worried. The idea of altering human DNA, possibly creating designer babies, or widening the gap between the rich and the poor felt overwhelming and even dangerous. But through this discussion, I learned that while those risks are real, CRISPR also holds incredible promise. It can treat serious genetic disorders, improve lives, and even help solve environmental problems if used responsibly. What really stuck to me is that this technology doesn't exist in isolation. It's shaped by who's using it and why. That's why these conversations matter so much. We have to be informed, ask the right questions, and help guide how CRISPR is used. It's not just about editing genes, it's about shaping the future. And I've learned that we all have the voice in how the future unfolds.
Working on this podcast and diving deep into the ethics and future of CRISPR was genuinely a rewarding experience. Not only did it open up complex conversations about science, society, and fairness, but it also highlighted just how much innovation and responsibility go hand in hand. The topic pushed me to think critically about where biotechnology is headed and how important it is to make sure that these advancements benefit everyone, not just a select few. Beyond the series discussions, I also had so much fun creating this project. From planning the interview questions to having a thoughtful conversation with an expert, it was exciting to see all the pieces come together. It made the process of learning feel creative and engaging, and it reminded me why exploring new ideas and technologies can be both meaningful and enjoyable.
I had so much fun and learned an incredible amount from this epic opportunity. It was both exciting and enriching, allowing me to grow in ways I hadn't expected. Every moment was filled with valuable experiences, new insights, and unforgettable memories. I'm truly grateful to have been a part of it and to learn more about CRISPR. This has really opened my eyes on how this amazing tool is used.
Creating this podcast on CRISPR has highlighted both its incredible potential and the ethical challenges it presents. We've learned that while CRISPR can prevent genetic diseases, its use for enhancement raises important questions about fairness, inequality, and the future of human diversity. The key takeaway is that we explore this powerful tool. We must approach it with caution, ensuring that ethical considerations guide its development and use. It's a reminder that innovation must always be balanced with responsibility.
Yeah, working on this podcast has honestly been one of the most fun and rewarding experiences I've had in a class. From the very beginning, it felt like we weren't just completing an assignment, we were building something meaningful. The idea of exploring the ethics of CRISPR sounded so cool on paper, but I didn't realize just how deep we'd go and how much I'd actually enjoy the entire process. Behind the scenes, there was a lot that went into this, from brainstorming episode ideas to writing questions and recording interviews and editing audios. It was definitely a grind sometimes. But it never felt like work in the traditional sense. Every part of the process, even the messy technical stuff, had this creative energy to it that made me look forward to sitting down and working on this project. One of the most rewarding parts for me was seeing how the pieces came together. As I mentioned, a lot of times in this episode, actually, I got to interview a grad student who's working in microbiology research. And the conversation that came out of that was genuinely eye-opening. It reminded me that science doesn't exist in a vacuum. There's so much more, so much ethical gray area that we don't always talk about, especially when it comes to gene editing in non-human organisms. Getting to have these discussions and then share it with others felt powerful. And I have to give a huge shout out to all my co-hosts. Working with them made the whole experience even better. We all brought different perspectives, different energies, and somehow it just clicked. We supported each other, bounced ideas around, and had a lot of laughs in the process. That collaborative vibe was just a big part of what made this class feel so different from others. It felt like a team effort, not just individual work. This class has definitely left a mark on me. It pushed me to think critically, communicate clearly, and step outside of my usual academic bubble. I'm walking away from it not just with a podcast, but with real skills and real memories and real friends that I know I'll carry forward.
And that's a wrap on Editing Humanity for now.
CRISPR is still developing, so are the conversations around it. We're not done asking questions, none of us are. But for this podcast, this chapter, this crew, we're pressing pause.
Thank you for listening, for thinking, and for being part of this ride. We've edited a few genes, sure, but more importantly, we've edited how we see the future.
We'll catch you on the next frontier.